All right, let's get started. Oh, I need to make a couple adjustments right quick. Oh, that's better. All right, now it's time to get started. Welcome to Git Quick Start. This is going to be a fast introduction to Git and GitHub. Hopefully it won't take too terribly long. So what I wanted to cover in this course is some core concepts. Basically, hopefully you know why you want to use source control, and you have at least an interest in Git. We'll cover the installation of Git on Windows, Mac, and Linux. Now, since I'm recording on a Mac, I already have Git installed, but I'll show you the steps that I went through. We'll do an introduction to Git using the approach that I call the remote first approach, which is starting on GitHub and then going to your local system and then back again. This is a very basic workflow, very common workflow, and in doing so, I'll be able to show you most of the basic commands that you would use. Before moving on to the second part of the course, I'll be installing Atom, which is a text editor, which I'll be using on the second part, which will be the local first workflow. And this is the case where you want to start on your system first because you're not sure if you want to use GitHub or maybe a different hosting service, or perhaps you have a lot of existing code. So if you have an existing project you want to put under source code control, then you might use the local first workflow approach. I do have a handful of assumptions here. Obviously, you need to have some degree of basic computer skills. You have the ability to install software, not just the ability from an understanding standpoint, but also the admin rights required in some cases. I'm going to assume that you have some degree of an understanding that you need source control. This would usually be people that really do any kind of coding whatsoever. So like a freelancer, web developer, programmer, a graphic designer, really anyone that deals with any kind of code. And there's source control value. That is the idea that, if you've done anything in the industry and where you have worked on something a really long time and then you lost it all because your hard drive crashed, then you understand the value of source control. You understand the value of source control when it comes to development. And of course, you're here, so you're interested in learning about Git. Git is the most popular source control tool out there right now, so that's one of the reasons why I do courses on it. So for my YouTube audience, what I'm planning to do is provide this YouTube stream immediately, unedited, and then I'll be replacing it with a better version later. So the production quality, which is what I would consider a course, will be on this YouTube channel. So subscribe to this to get that more polished version of this. And also I'll be, depending on how well this turns out, I'll be turning this into a free course on Udemy, as well as some other platforms that I put my courses on. My model right now is that I do free short intro courses on Udemy on YouTube, and I put my premium courses on Udemy and others. I just started a Patreon, and we'll see how well that goes. I'm going to try to put as much of my premium content out there and see if that goes well. And of course, I'm always available for private group or training, private group or team training, as well as consulting when it comes to any kind of DevOps type of topics. And I have some links in my description below. So, a bit about me. Let me get rid of the double image here. I'm a lead software engineer, and I'm an online instructor. I've been a lead software engineer. I've been doing programming in some sort of capacity for the last 20 years. I'm currently on a continuous integration delivery team, and I've become my company's resident expert on Git and GitHub, just sort of as an extension of that continuous delivery role that I play. I'm also a technical trainer. At my current day job, I've trained hundreds of fellow developers. In particular, I helped convert over everyone from their legacy source control tools, which were Perforce, Subversion, and IBM's ClearCase, over to Git and GitHub. I've been teaching online now for about 4 years, and I have about 19 courses now. I have 19 and counting courses, and some of them I have a couple courses that I co-instruct with, so I'm not the primary subject matter expert, but I do have at least 16 of my courses that are solely me. For this course, I will be doing a lot with the command line, and for those of you who are coming from more of a graphical interface like Windows, you might be wondering why. So we're going to be starting command line. I will be using some other tools that aren't exclusively command line, but a lot of the focus will be on the command line. And you know, of course, you're wondering, so why do that? Don't you know what year it is? That sort of thing. And there are a lot of good reasons to start with command line. First of all, there's a historical reason. Now, of course, this is probably one of the weakest reasons why you'd want to start this way. But historically, Git has always been done for the command line. All the new features come out with the command line first, and a lot of times a lot of the powerful features are on the command line. In my mind, actually, the most compelling reason for going command line first is that online help. If you do a Google search, go to any site, weblogs or like Stack Overflow, and just query, hey, how do you do whatever it is using Git, your response is going to be a series of commands. It's not going to be right-click on this and then go to that window. It's not going to be any of that. It's going to be type in this arcane command. And you can blame the internet for that, but one of the reasons is that all the Git commands work basically the same way across all the platforms. So it's the simplest way to give an answer without going through a game of 20 questions on what platform you're running. All the power is on the command line. This goes back to the GUI sometimes does not have all the features implemented, and so you have the full feature set using the command line. And as I mentioned before, the command line is consistent, and whether you're using terminal on the Mac and Linux or whether you're using Git Bash on Windows, at least the Git commands are the same. Now, the other commands, when it comes to actually interacting with the shell environment you're in, may be different, but the Git commands will be the same. And graphical clients, I really don't have a major problem with them. To me, they're what you do after you've learned at least the major parts of Git using the command line, and then you can augment your Git experience with the graphical clients. And I do this all the time. I spend about 50-50 of my time between graphical clients, whether it's an IDE integration or if it's a standalone client, and then, of course, the command line. And as graphical clients become more sophisticated or more compelling, then, that shift may change over time. All right, so let's take a moment to look at some of the key concepts regarding Git source control before we start diving into the examples. We're going to start with the Git repository. Now, the Git repository is really two concepts in one. The working directory, which is what most people are familiar with, and they'll say, I'm going to go to my Git repo on my local system. What they're usually referring to is their local working directory. However, technically speaking, the working directory is not actually the Git repository. It's just a set of files and folders managed by Git. The Git repository itself is actually in a special .git folder within the working folder. And that's usually and the Git folder is at the root of the working directory tree. So unlike other source control tools like Subversion, where you might have like a .svn folder at every folder level, there's only one .git folder, and that's at the root of the working tree. Within a Git repository, there are 3 local states that are managed by Git. One is the working directory. That's your files and folders that are being managed by Git. The staging area, and the repository itself. And the workflow for creating a commit or changes in the repository follows what we call a 2-stage commit process. Basically, we don't go directly into the repository. We first stage our changes. So we'll start with some sort of file in our working directory. We'll then add those changes to our staging area. Once those things are in the staging area, the copy of the files we have will be in both the staging area and the working directory. Then we're ready for the actual commit, which will take any changes that are in the staging area and put them in the Git repository. Now, at this point, our changes are in both the Git repository and the working directory. So this is the full workflow. We start on the working directory side, put everything in the staging area, and finally commit our changes into the directory. And then finally commit our changes directly into the repository. Nothing's actually affecting the history until you've committed the changes. So staging is just a holding area where you can build up a fully atomic commit. But wait, there's more. I like to think of a remote, or that is a version of your repository that's hosted somewhere else, as kind of sort of like a fourth state, even though it's not really a fourth state. A remote repository is a full Git repository with its own internal set of 3 local states, but it's being managed by a remote system like GitHub. But from a conceptual standpoint, it feels like it's a fourth state. And in a lot of cases, people don't even think of that. A lot of people think of the remote as like you've actually finally committed your changes when it's on the remote. And we do this with the push command, and we'll cover this a bit later. But it will take anything that's in your local repository and make sure they're on the remote repository. With the remote involved, this is really what the full workflow would look like. So we have the 2-stage commit, or the 3 local repository, or the 3 local states on the local side. And then we have the conceptual idea of the remote as the 4th and final state. All right, the default branch. First, let's talk about the commits. So commits are the series of changes at any point in time on a timeline that's captured in Git. And typically these things are recorded. They have an identifier for each commit. Each commit can have multiple changes associated with them. They could be multiple changes to one file, or they can be spread out across several files, or any kind of combination of that. And the commits are identified by a SHA-1 hash, and this hash can be abbreviated depending on how large the Git repository is. Typically, you can abbreviate it by just specifying the first 6 or 7 digits of the SHA-1 hash. By default, we get a single branch. So a branch is simply a timeline, and we get one for free called master. That's our default. Now, technically, we could change the name of master to something else, but we commonly don't, because by convention, your main or primary branch in Git is going to be called master, and that's what everyone's expecting. So it's nice to follow that convention. All right, let's head over and look at installing Git. We're going to cover this on Windows, Mac, and Linux. Just some general notes about my installation process. Because this is a quote-unquote quick install approach, I do have to sort of abbreviate a few things. So we have Google Chrome is my default browser for all my training courses. Honestly, these days, any modern browser will work, even the default browser that comes with your operating system, provided you're running something that's been out in the last 5 years. I have made a few operating system adjustments. For example, I'm working with a clean install on Linux and on Windows. And I've done that by using a virtual machine. That's really the only way I can kind of make this magic happen. I've made it so there's as few distractions as possible, and I have made a few adjustments to the operating system so that it'll look a little better to those of you watching. I also went ahead and downloaded a script called Git Prompt. This sort of allows me to standardize how my prompt looks on all the operating systems I have. This is really more important for the Mac and Linux people, because Mac and Linux don't display both of those. For Mac and Linux, the terminal does not display which branch you're on by default, but Git Bash does, so there's not a huge need to do this on Windows, but I do it on Windows anyway to keep it consistent. And you might be wondering, hey, why should I watch you go through the installation process? Well, if it's on the stream, well, you're kind of, captive audience at this point. But there are a handful of tricks along the way, a few things that are not exactly the default, and that's especially true for Windows. I also like to make sure that I always show my work, and that's for the benefit of those that really want to follow along closely and do exactly what I'm doing. And if something isn't working exactly the way they expect it, it might be because their installation isn't set up the way that I have mine set up. And I do have my installation notes available. I put them on my website, and they'll be made available in their resources for whatever platform you're viewing this on. So the process is we're going to install Git. We're going to do that on Windows, Mac, and Linux. I'll go over the help and documentation, and we'll do the minimal configuration required. And Git does require just a little bit of setup before we can. Git does require a little bit of documentation. Sorry, Git does require a little bit of configuration before you can do really much with it. This is typically just your name and email address. We'll set up a couple of other things as well while we're there. So I'm going to go ahead and get started with Windows. Let me hop over to my Windows system. And I'm going to fire up my browser. Let's go to the official Git website at git-scm.com. It should automatically detect that I'm running Windows and provide me the appropriate download button. So let's click on that. While this is downloading, I'm going to double check to make sure it actually figured out the right version. I want to make sure it got the 64-bit version. I have seen this occasionally try to give me the 32-bit version. And if that happens, you can go to the different link to make sure you get the right version for your system. In the grand scheme of things, it probably doesn't matter a whole lot, but I do prefer to keep consistent with what my operating system is expecting. So 32 bits for 32-bit systems and 64-bit for 64-bit systems. Hopefully you know what type of system you have running. I'm going to use my browser's run feature basically in Chrome that is open. I'll get a user access control dialog and just say yes. And then we start our setup wizard. The first page, of course, is just a license agreement. I would, of course, always recommend reading those, even though I almost never do. This destination is fine. I'm just going to let it install in its default location. And then this is also going to be fine, except I do like to add the icons to the desktop. Other than that, everything is the same. Start menu location is fine as well. And this is a relatively new screen. By default, you didn't get a choice on which editor to use with Git. You had to sort of either been okay with Vim or set it up separately after the install. Here it gives you the opportunity to set this up during the install. I don't exactly like Vim. If you're a big VI person, which if you're on Windows you probably aren't, then more power to you. But I like using Nano, at least starting out. It's a very easy to use command line driven text editor. I'm going to click next. This adjusting path thing is really what parts of Git am I going to expose to the system. The first choice only installs Git into the Git Bash environment only. The middle option is my favorite because it will allow you to run Git not only from Git Bash, but also from the Windows command prompt. And depending on how you use your system, this might actually be the best and most flexible without making any changes to your system that you might regret. The last option might replace a few key tools that your system's expecting with the Git version of them, so I don't recommend using the last option. So we're going to stick with the middle one. Here, I would only consider the Windows Secure Channel library if you're in an Active Directory managed domain. So if you're in a large enterprise, then this might be a good option. Otherwise, stick with the OpenSSL library. This screen is definitely more along the lines of personal choice. If your team is exclusively Windows only, then you might consider using the last option, which is check in as is and commit as is. The top option, Git tries to play nice with you from a Windows user perspective and converts anything that was checked in as a Unix line ending and gives you a Windows style line ending. These days, I don't think that's really necessary, because even on Windows, most text editors understand the Unix line endings. My favorite option in this case is actually the middle option, which allows you to check out as is and to commit as Unix and to commit as the Unix line endings. So if you're a Windows user, but say you have team members that are using Mac or Linux, then eventually everything you check in will be Unix style. So this is a great option for cross-platform teams, and it's also the recommendation for any project you join that is an open source project or a project that's shared with lots of different developers that you may not know what their systems are. That's kind of like the safest option for me. The terminal emulator, I always just stick with the min-tty. For the extra options, I leave these two checked. The middle option here is going to be very useful for us because it will cache our credentials when we attempt to authenticate with GitHub. There are some experimental features that are being added, and this is one of these things where the setup wizard changes over time. So, for example, this screen wasn't there just a few revisions ago. Right now, I'm not going to bother with anything experimental. We really don't need them in this course. So once you get to the end of the wizard of questions, you can click on the final install button to actually install Git. All right, just a second. All right, once you've made it to the last screen, I'm going to uncheck this for now and click Finish. Let's go ahead for now. Let's close our browser. And we should have a Git Bash icon now on our desktop. Let's go ahead and open that up. And your screen may look a little different because I've already put in some scripts that will detect that I'm running inside a Bash environment and change it accordingly. But one thing that will be the same or very similar is that it will look very small. If I type git version, it will print out the version that I'm running. But let's go ahead and fix this. And go to Options. I'm going to use the block cursor. Under Text, I'm going to change my font and size. I prefer using Consolas. And let's go for 28. Now you're going to want to use a setting that makes the most sense for your system. I'm actually on a very large display, and so I need to go pretty big. If you're on a 4K display, you might even need a larger font than I'm using. Okay. And go to Window. And let's try 120. And I'm going to bump this up to 32. Again, your display may need different values. Apply. And then save. Let's see how that works. To get the full effect, let's close Git Bash. And let's fire it up again. All right. Now my Git Bash terminal covers most of my screen, which is exactly what I want. All right, let's look at some help. If we type simply git help, Git responds with basically how do you use the git command. And we can go a little further deeper. We can go a little deeper with git help-a. This lists all the different commands we can use. And the git command that we're going to use next is going to be the git config command. So let's get help about that. To get help about a specific command, you're going to type git help and then the command you want help about. Git help config. On Windows, that will invoke your default system's web browser, and it will take you to a manual page or a web page with documentation about that specific command. If you're on a different system, you'll have a different experience. Let's go ahead and close out. An alternative way to do this is to use the git command space and then the command you want to get help about space and then -- help as an option. This does the exact same thing. In fact, we can even combine the two and get help about the help command. Get help, which is the actual command we want help about, -- help option. And there we are. We have help about help. Now let's go to the web browser. If we go to the git-scm website, we can also navigate to that specific help as well by going into documentation. Once there, you just go into reference. And now we have a nice listing of all different commands you can do. And so you can click on the command that we'd be interested in. So the next command we'll be using is the config command. And there we are. We have information about the git config command. It's not the exact same page, but it has very similar information. All right. Now let's go ahead and configure Git to work, basically to work. There's a handful of commands that we can use with Git that don't require this configuration, but to do anything serious, you do need to go ahead and set up at least your name and your email. So type git config, and we need to use -- global because we're setting up the configuration for what Git considers the global level. And it's a bit of a misnomer because really when I think global, I think the entire system, and that is actually the system level, which is stored within the gits installed directory. -- global actually means user level, so that will be stored in our user's home directory. In fact, let's look at that now before we do that. So do pwd, that's print working directory, and in the nomenclature that Git Bash uses, it prefaces everything with /c. So instead of C:, it's /c, and then the path to where we are, which is /user/ my username. If I use the ls command, which is equivalent to the dir command, we can see the listing of files and folders that we have available. And I have a handful of hidden files, but one thing I don't have is the .git-config file, which is the configuration file that is created or managed by Git when we use the -- global option with the configure command. So let's go ahead and do that now. Git config -- global, and then the setting we want to set, which will be user.name, then in double quotes, then put your name. We're going to do this again. This time the setting is going to be user.email, and then in double quotes your email address. And I do recommend that you keep your email address consistent with the email address you're planning to use on GitHub. Now, for those that are ultra sensitive or privacy concerned about putting your email address out there on the internet, GitHub does have a email address that you can use that's sort of a @no-reply type of thing if you're really that particular. However, this doesn't do anyone any real benefit because typically people want to find out who made certain commits and reach out to you and say, hey, why did you make those changes, or whatever the case may be about tracking down, the whole point of Git source control, basically. Now, if I list the files and folders here, I should have a .git-config file, which I do. We can open it up with Nano, which is that little text editor that we configured earlier on. And Git uses something that looks very similar to Windows users that are familiar with INI files, sort of back in the day, where we have a section in brackets followed by individual properties. In this case, they're actually indented a bit. So under the user section, we have a name and we have an email attribute with those settings accordingly. We can exit out of this by doing Control X. And that was really the minimal configuration we need. I'm going to do two other settings while we're here. I'm going to go ahead and clear git config -- global. Core.editor. I'm going to set this to nano. Now this is going to be at the user level. So if we went through the installation process and set Vim to be our default editor, but say I log into the system and I really prefer nano, then I could use this setting to override that at the system level. So the user level or global level overrides anything at the system level. And then when we get to that, anything at the repository level ultimately wins. There's one other setting that's a little hard to explain, but that's called push.default. And I'm going to set this to simple, which is actually the default. Ever since Git 2.0, they moved to the simple as the default for this setting, but they have been warning people, hey, we're going to be making this change leading up to Git 2.0 and even afterwards. So in order to hush that warning message, I like to go ahead and explicitly set it. At some point, this will become really unnecessary, but it's just one setting and it's not that big a deal. So setting nano to the core editor. Now that's going to be the default editor that Git uses for any of its internal commands that wants to invoke a text editor as part of that command. We can actually test it out. Let's test it out right now by using git config -- global -e, which means open the configuration file using the default editor. When we do that, our .git-config file is opened for us, and you can see the settings we've added, including the 2 additional settings we set up after we set up our user settings. All right, so once you've done everything you want to do within Git Bash, to exit out, you can click the little X arrow if you the X icon, or you can simply type exit. And that's it. So we went to the official Git website. We downloaded Git. And while most of the defaults were okay, we did make a few changes, and we made some tweaks to the Git Bash. So at least for your benefit, so it actually looks readable. Went over some help documentation and our minimal configuration, which we already just did the demo for. All right, let's switch over to Git for macOS 10. I recommend using the command line developer tools. This is something that's supplied by Apple. If you already have Xcode, then you already have this. Really the only downside here is that the version of Git that Apple provides is slightly behind the official released version. For most people, this is not that big a deal. This is about as dead simple and easy as you can get. And you don't have to worry about any conflicts later. That's usually one of the problems I have with one of the other approaches to installing Git, is that, well, then you have to do extra steps in order to make sure that your system or your command session uses the Git you installed instead of the one provided by Apple. And because of all the, because of that, and the downside being the Git version being a little behind is not that big a deal, this is my recommended approach. There's a little tweak though. Every time Apple does an update to their operating system, we have to reinstall the command line tools for some reason, including Git. It's not that big a deal. It's just if you try to use the Git command right after an OS upgrade, you may get an error message. It's happened to me in the last at least 3 upgrades. And really, the fastest way to get started with installing Git is to see if you already have Git. If Git responds with a version number, then you're done. You don't have to install anything. It's already been installed. However, if you don't have Git installed, you're going to end up with a screen like this, where Apple's going to prompt you, hey, do you want to install? And hopefully you'll say install. If you click on install, you install the developer command line tools, which includes Git among other little utilities. Or you can click on Git Xcode, which will route you over to the App Mac Store, which you can download the latest, greatest Xcode version. All right, let me show you what I have. So here I'm logged into my system. This is on my Mac. You see I'm here in my user's home directory. If I do git version, you can see that I already have Git installed. And that's because, well, the Mac is my main system, and I already went through this process of installing the command line tools, which is where I actually got my screenshot from. We can walk through the same steps as before to do the configuration. Now, before we do that, I'll show you the help command. Now, I won't do the website stuff because that's pretty much universal. So if you were there, you watched the Windows side of things where I opened up Chrome and went to the Git website. All that works the same way. So I'll just show you how it works with the git help command. Like before, if we do git help -a, we get that listing. The difference here is now if I get help on a particular command, git config --help, it comes back a little differently. Instead of invoking a web browser like we did on the Windows side, it actually invokes a man style type of utility that will display inline inside the command prompt or inside the terminal environment. I can page through by just tapping on my spacebar. And when I'm done, press Q to exit out. And that's basically it. All the other permutations I went over before apply here as well, except that we would invoke the man page instead of the web browser. I'm going to do the same thing we did before with git config --global user.name and set my name. Same here as well with my email address, git config --global user.email, then in double quotes, my email address. I'll also set Nano to be my core editor. And push.default is simple. Now if I use git config --global -e, that brings up Nano on my Mac within my terminal system. and that brings up the .git config file from my user's home directory. All right. Like I mentioned before, you may have to do a different command. You could do the xcode-select --install command after a macOS upgrade. I'm going to talk about major upgrades. So that would be going from 10.12 to 10.13 to 10.14, not the patch releases where you go into like 10.13.6 to 10.13.7 or something like that. The patch releases you don't have to worry about. The major yearly releases is what we're doing now. That you would have to do the Xcode select after that. And then, of course, you want to verify with git version at the end. Of course, this isn't the other way. Of course, this isn't the only way to install Git. Of course, this isn't the only way to install Git on Mac. You can use the Mac install image from the git-scm website. That's the official install image. You can use Homebrew, Mac ports. There are some issues with this approach. You would have to update your path, at least for your Bash session, and there's ways of doing that. Otherwise, it gets confused with apt-get, and in some cases, still may get confused with apt-get. If you use Homebrew, well, it's simply brew install git. Then you'll have to update your bash RC file, something like this. Wherever brew installs git, that's where you would have to put that path first, so that it will find the git install or the git binary in that location before it finds it in the normal location. And then just verify it with git version. Make sure it's actually using the one that you think you're using. Have the same concept with Mac ports, but with Mac ports you have to use sudo. So hopefully you need to have sudo access in order to do that. And then verify with git version. All right, let's switch over to doing things on Linux. With the Debian family, it's pretty straightforward. The Debian family is like Debian, Ubuntu, Linux Mint, and all those relatives, basically. You're going to use apt-get or simply apt and install command, then git. So apt-get, install, git. That's all you need to do. After that, git version to verify. So let's go ahead and do that. I'm running Linux Mint. That's sort of my favorite flavor of Linux, at least running on the desktop. There are literally hundreds of different distributions of Linux. So it's one of those things where you, instead of covering all of them, you would just pick your favorite one and go with it. Most Linux users understand their system well enough that they can kind of figure out what they need to do. So right now, if I do a which get, I come back with nothing, which means which can't find get anywhere on my path. So let's install it. apt-get, install git. And since I know for sure I want it, then I'll do -y here at the end just to avoid that prompt. Oh, yes, you need to do sudo. Sorry. Oh, let's do that again. So to install git, sudo apt-get install git-y. Put in my password, and then we're able to move forward. And while I'm here, if you think you want to use the official Git GUI, we can do. First of all, let's do Git version. All right, so we have 2.17.1. The downside of using your package manager is that, like on the Apple side of things, you're going to be slightly out of date. That's just the nature of the beast when it comes to working with package managers from your distribution of Git, your distribution of Linux. And in my opinion, it's not worth the hassle to like compile Git from source or anything to make sure you have the latest greatest. That's just, it's not worth it. All right, so we're going to, one extra thing, is sort of a bonus here. Sudo apt-get install git-GUI. And that will install the official GUI that comes with Git as well. Now, I won't necessarily cover that in this course, but if you want to play with it, you can. Now, getting help, you'll run into the same thing that we have with the other systems where stuff on the browser works the same way. So I'm not going to bother going through all of that. Kind of the same way with the Mac. If you do it on the terminal, if you do it inside, like in the case of the Mac, getting help on Linux within the terminal, you come back with a man page. You can press Q to quit as well. All right, so now let's go ahead and set up our Git configuration. Git config -- global user.name. And then I'll put my name. And that I cut off a little sooner than I was expecting, but that's okay. We can verify things by git config -- global -- list. So it looks like those are set up correctly. All right. All right, let me set up the other two settings. My core editor, set the nano. And push.default to simple. Now if I do git config -- global -e, I'll bring up nano. Now that we have nano available on Windows, nano is sort of the universal text editor that doesn't hurt when you use it. That's available on all the systems. So Mac, Windows, and Linux, which is nice. So I'm not a huge fan of VI. I know that upsets all the VI users, but tough. All right, and clear. Let's head back over to our slides. All right. For those poor, unfortunate souls that are using Red Hat or CentOS, I mean that in the most lovingly way, and really old version of Fedora. If you're using a really old version of Fedora, then you're really doing that to yourself. I have no sympathy for you at that point. you're going to do yum install git. Of course, this is as a user, that's as a root user or as sudo. You're going to verify with git version. And if you're using the newer versions of Fedora, basically since it's been available since 18 and default since 22, and that's the newfangled package manager called DNF. It's the successor to yum, and same concept as the root user or with sudo in front. You're going to run DNF install git. Kind of see there's sort of a pattern here. Again, we're going to verify with git version, and hopefully you get a version back. Now, to the main event. We're going to be starting with our actual GitHub Quick Start. We're going to do the remote first workflow. However, first you got to start with GitHub. So what is GitHub? Well, it's a hosting service. It hosts Git repositories. So some people, and I mention this because some people will confuse Git and GitHub. They'll say, they'll think that GitHub is Git or that Git is GitHub, and it's not. Git is the source control tool. That's where you check in stuff into your repository. And GitHub is the hosting service. GitHub is available at github.com. You can sign up if you don't already have an account, or sign in if you have an existing account. Either way is fine. Now, I've taken these screenshots from my sign-up process that I did for my Radiant student account. Basically, you're going to start off with a GitHub on the GitHub website at github.com. Right now, at least on their main page, they have a sign-up form that you can fill out and sign up for an account, which is the approach I took. So fill in username that you want. Fill out the username that you think you want. If it's available, you should get the green check. If not, then it'll kind of tell you that you need to kind of keep typing until you get one that isn't available yet, and that is yours. Then type in the email address you want to associate with your account, and then type in a password that you want to use to secure your account. And right now, it wants at least one letter, one numeral, and a minimum of 7 characters. Then click on the green Sign Up for GitHub button to sort of advance to the next screen. Right now, at least, you'll have to click on a green Create an Account button. Now, one thing I will say is that GitHub.com is not managed by me. I have no way of controlling any of the content on their website, and they make frequent updates to their website. So this wizard may change in the future. And it has changed several times since I have tried creating various accounts for testing and training purposes. At some point, you'll be landing on a welcome page, and you may be asked to sign up for a paid account. By default, you'll be put on the free account, and then you can opt to go to the paid account. The difference really is that the paid account allows you to create private repositories, but you get an unlimited amount of public repositories for the free account. And that's all we need for this course. You may be prompted for a survey. You can skip it or whatever you want to do. And then eventually you'll be sent an email for verification. So in order to unlock all the features of GitHub, you need to go ahead and do the verification. It's sort of a it's sort of one of these double opt-in type things where they send you the email to make sure you gave them a real email address as opposed to a fake email address. So kind of keep that in mind when you're signing up. And once you click on that link to verify, you should have like a little notification at like a little banner at the top that says your email was verified, and then you're good to go. All right, let's sign in. I'm going to do this through the Windows VM since I know most users are using Windows. I'm going to go to github.com. And I'm going to go ahead and sign in since I already have an account. I have Radiant Student. All right, so I did actually type in my password correctly, which is always nice. All right, so the first thing we want to do once we're logged into GitHub is we want to create a repository. This is why I call this the remote first approach. I'm starting on the remote side, or in the cloud or on the internet, however you want to look at. Basically, I'm going to create my repository here out on GitHub, and then we'll clone that or create a copy locally after we've done that. So click on the new repository button. One thing I've noticed is this sometimes has jumped around in the past. It used to be over here somewhere. Now it's over here. So again, GitHub likes to change their website a lot. Once you land on the Create New Repository page, you'll be the only owner here. This dropdown may get larger as you are associated with other accounts or what they call organizations here. But it's just starting out. Owner is the only thing I have, so that's my account. Repository names do have to be unique per account. So someone else could use the same name of my repository, but I can't have two on the same account named the same thing, which, would make sense. I do have a preference for using all lowercase and separating my words with dashes. There's only a handful of real restrictions. One of the neat things that GitHub will do is it will kind of convert any characters that are not really supported into supported characters by default. So it'll turn a space into an underscore or a dash for you. Description is optional, but I do like putting one. Helps if I spell correctly. This is an example repository. We're going to leave this as public. If you do click on private, then you'll be prompted to upgrade your account. But we don't need that. We'll just leave it as public. I really don't care if the whole world can see my README file. And this part is critical. We do want to initialize the repository with a README file. This really makes this whole approach possible. The reason why is that when we do that, Git will create our first commit and seed our repository with a README file. We don't need anything else, and so we're ready to create our repository. Here we go. We have landed on our repository now that we've created that in GitHub. We have one commit, so if we go in here, we can see that we have our initial commit and that we have our SHA ID. Again, this is abbreviated SHA ID that's associated with this particular commit. If I click back on code, I go back to the main page, and we have our README file, which is readme.md. The MD stands for Markdown. And Markdown is just a special format for text files. And by default, GitHub will render any readme.md file in the folder that you're in. So for here, it populated this already. So it'll give me a first level header of GitHub-demo, which is named after our repo, and then it uses my description as a paragraph underneath. And that's it. That's our repository. Now, in order to move forward, let's go ahead and jump over. You can actually edit this if you want. I'm going to cancel out of that. All right, let's hop back over to our presentation. All right, now we're ready to do our local steps. We're going to let's go ahead and leave our browser open because we're going to be coming back and forth. Go ahead and invoke Git Bash. We're going to open that up. And I'm going to situate these so that I can access both of them relatively easily. So now I can hop back and forth. Yeah, that works well. I'm starting in my user's home directory, but I like to set up my own space within my user's home directory for all my projects that I'm working on. I'm going to call this directory projects. So I'm going to make a directory called projects. This assumes there isn't one yet. If I do ls, then we have a projects folder. There it is. If I use the cd command to change directory, go into projects. Now my prompt changes to show me that I'm in my projects folder. Now if I print my working directory, you can see where I'm at. And this is where we want to create our local version of our repository. In order to copy that stuff down, we're going to use the command called clone. In order to do that, though, we need to get the URL from which to clone. If we go to the nice green button that says clone or download, expand that out. Here, let me hide myself right quick. We can see we have the clone with HTTPS. And right now, we'll stick with HTTPS. There are other methods, but this works, and it works pretty well. Once we have that copied, we're going to hop back over to our terminal and use the git clone command. Git clone, and then we're going to paste in the URL we just copied. In Git Bash, it's a little different. So instead of the standard Control-V, Control-C, that kind of stuff, you need to use Shift Insert. And that will paste in the content. Or you can right-click and paste. Either way will be fine. Once your GitHub URL is pasted in, then you press the Enter button to clone. Now, since this is a public repo, it's not going to prompt you for your username and password because anyone can clone your repo. That's one of the advantages and actually one of the disadvantages of a public repo. One of the aliases I set up in Git Bash is LL, which is the same thing as ls-la. I set up what's known as a bash alias. So effectively, I get to create my own commands doing that. So I'm going to use LL, which is the same thing. I see in this case I have a GitHub-demo folder. If you don't specify anything at the very end, when git clone runs, it will create a folder named after your repository. Let's go into that. cd space github-demo. Now we're in it. Also, we can see that the magic of the git prompt is working. So in addition to telling me which folder I'm in, I now have in parentheses which branch I'm on. And as I mentioned before, by default, our main branch is called master. If I do an ls, you can see that we have our README file, which is what we got from GitHub. Do an ll that lists everything. We have the .git repo, which I mentioned before when we went over some of the core concepts. Where we start in our working directory, that's the files that we're normally familiar with. And then the .git folder is the actual repository. In fact, if we go into it, we can see a whole bunch of really internal files that make up the Git repository. And in this case, my Git prompt kind of warns me, hey, you're in a Git repo. So with the all caps git_dir, hey, you're in the actual Git directory. Don't do anything here. There's very little that you would actually want to configure or change here. All right, so we're back. We have our README file and our .git folder. So we have successfully cloned our repo. Well, since we are in a Git repository, we can use a git status command, which we'll be using quite often to kind of get an idea of what the status of our repository is. And it tells us, and it reminds us that we're on the master branch. It tells us that we're up to date with origin master. And that's just another way of saying origin, that's the repository from which we cloned from. That's where we originated from. And master is the master branch on our origin repository, basically GitHub. So the master branch on GitHub is up to date with our local repository on the master branch. Since we haven't done anything yet, there's nothing to commit, and that our working tree, that is our working directory recursively, is clean. There's no changes that Git is seeing that need to be dealt with in any way. All right, I think we're ready for the next step. On to the two-phase commit. We're going to walk through the 3 local states in Git on our way to our first commit. And we'll be doing this by creating a new file and also modifying an existing file. As a quick reminder, there are 3 states in Git. We have our working folder, we have our staging area, and we have our Git repository. So let's start off in our working directory. We have our README file and that we're in our Git repository, or the working directory of our Git repository. Let's create a new file. I'm going I'm going to use my Nano text editor, and I'm going to create a new file called start.txt. And with Nano, you can simply specify the name of a file you wish to create. And whatever you want to put in here is fine. It doesn't matter. This is an example text file. Now, when I use the key combination of Control X, Nano will say, oh, you have changes in your buffer. Basically, it sees that we've made changes in the text area, and would I like to save them? So if you press Y, then you save the changes. In doing so, you create the new file. It's going to prompt me, even though I specified it in the command prompt when I launched Nano, it'll give me the opportunity to actually change the name. If I just press enter, it will keep that name and write that out. So now if I do an LL, I see that we have both the README file and our start.txt file. Now you're probably wondering, hey, why aren't you using a real example? And I actually am. This is a real example. It doesn't matter that start doesn't end with .js or .java or .rb or .py. Doesn't matter. Source code is text. And that's what Git tracks. It doesn't track source code. It tracks text and the differences in text. And that's an important distinction. So don't get hung up that I'm not using your favorite language. I'm using text because that's pretty universal, and the Python people aren't going to care that much that I'm using Java, or the Java are upset because I'm using Groovy or Ruby or whatever favorite languages are out there. Just all that is just nonsense. We're just going to use text files. All right. Well, let's ask Git what it thinks about our new file. So we have changes in our working directory. We have the same stuff that we had before. We're on the master branch, and that we're up to date with origin master. Same old so far. Now it tells us we have what's called untracked files. Now you're probably wondering, what the heck does that mean? Well, untracked, well, there's two types of files in Git. There's tracked and untracked. So it's pretty straightforward, right? Well, what that really means is that there are files that Git is worried about. It keeps track of them. And there are files that Git is not aware of yet. They're not tracking them. They're untracked. So, of course, new files that we haven't added to Git yet or haven't made Git aware of yet are, by default, untracked. So we have changes that are in the working directory. In this case, we have untracked files. We have new files. We need to use our add command to put whatever we want into the staging area. So let's do that now. We do this with the add command. Git add, and the name of the file we want to add. Now if we do a git status, we have a new state. It says that, like before, on master branch and up to date, and that we have changes to be committed. That's just Git's way of saying you have files that are in the staging area. So now we have changes in the staging area. Our file is in both the staging area and the working directory. In order to proceed, we need to actually follow through with the second phase of our commit by actually doing the commit. Went a little too fast there. All right. Gonna start over here. Git commit. And this time, I'm going to pass in the -m option. This allows me to do an inline commit message. You want your commit messages to be short, sweet, but descriptive. And as long as your commit messages are under 50 characters, then it's fine to do them inline. Technically, they can be as long as you want them to be, but there's a lot of tools that really prefer to have at least the first line of your commit message to be under 50 characters. First local commit, start.txt. Now with that, I have that I'm on master and the abbreviated SHA-1 associated with the commit that's involved here, along with the commit message that I just provided. It tells me that one file changed. Basically, it's the one file we have that we added. And there's one insert. Basically, there was one line that we inserted. Now, Git manages things through content changes. So, see, one insert, one line got changed or created. Since I'm on Git Bash, the create mode is always 100.644. And it tells us that we have the start.txt. So now we have our change in the Git repository. And when this happens, we're actually affecting history. Now if we do a git status, it tells us that we're, again, on the master branch. And now this time, it tells us that our branch is ahead of origin master by one commit. That is, our local branch master, we just created a new branch. We just created a new commit, right? We just added a commit, which means that our local repository on master is ahead of origin master, the Git repository that's hosted on GitHub. All right, so now we're ready for the next phase. But before I do that, there's a couple things I did want to cover that I didn't quite add in. First, I need to put I do want to do another commit, which is kind of nice. And maybe we'll combine this with another new file. nanosecond.txt. This is another file. I'm going to save that change. Now I have readme.md, have second.txt and start.txt, at least on the file system. If I do git status, it sees that I have an untracked file. Now, one thing I want to show you is that there is a special command to kind of tell what Git is tracking. To do that, we do the ls-files. So git ls-files. Oops, let me clear. Git ls-files. This tells me that I'm currently tracking, or the Git repository is tracking, the README and the start.txt. But Git does see the second.txt. We can add that. git add, and then our file name. And there we are. We have the new file. Now if we do a git ls-files, this is the point at which Git starts to care about the file. It's now tracking our second.txt file, whereas before it wasn't. We don't even have to complete the track. We don't even have to complete putting that file into Git, into the Git repository. At the moment that we put it in the staging area, Git is now tracking that file. Now, there was a couple of things that I did want to cover here, and that is, okay, great, I put something into the staging area. What if I didn't want to? Let's change something here first. Let's update our README file. Let me just change that heading so the hash mark in Markdown is a first level heading, similar to a H1 in HTML. Once I'm done with that change, I'll save that. Now if I do a git status, I have a combined status this time of that show things like changes to be committed, so it shows us what's currently in the staging area, and stuff that's not staged yet. You'll notice we have actually a different status here. We have something that says modified, and that just means that we have an existing file that has changes. All right. So we have, this is where we are. So we have a modified file that's not staged yet, and a new file that is staged. So if we do our git add readme, now we can do git status. Now, everything that's in the staging area, we have both the modified file and the new file. Now, this is a case where you might decide, you know what, I really don't want that change to be part of this commit. Maybe I want it to be part of another commit, or maybe I want to get rid of the file entirely. So we can do that. Let's say that we're not quite ready for the changes that we've made to the README file. So we really don't want those changes, at least not part of this commit. We can use git reset. We can just follow the instructions, basically, that our git status command gives us. It's going to be intuitive and kind of figure out, well, if you don't want this to be here, then here's what you can run to undo it. So we use git reset. Now, git reset is used for more than just undoing a stage, but we'll just follow the instructions here. We're going to use a special thing called head, and we can cover what that actually means later. And then the name of the file we want to unstage. So now we have unstaged the changes. So now if we do git status, we're back to where we were before we added our modified file into the staging area. So if we do git status again, it gives us some instructions here. So we could unstage the new file, or we can completely wipe out the changes that we made to our README file. Let's do that. Let's just say that I'm just not happy with any of the changes that I made to the README file, and I don't want to keep any of them. I just want to get back to the original version of that README file that's currently in the Git repository. I can use the git checkout command, 2 dashes, and then the name of the file. Now these 2 dashes are separated by spaces. So git space checkout space 2 dashes space and then the name of the file you want to completely undo. Now that we've done that, now we're back to only having changes in our staging area for second.txt. And we can confirm this by opening our README file. And now we're back to the original version of that README file. All right, so I'm going to exit out. Let's go ahead and move forward with our commit. Git commit -m, adding second file. Right, now we have 2 commits, and we can kind of show what that commit looks like. Git show head. You know, we mentioned what head is. We used head already to undo the staging, and head just refers to the last commit in the current branch. So if I show it, we show the commit that's involved. And you can see here we actually have the full SHA-1 hash that's associated with the commit. This is the full identifier. Underneath that, it shows myself as the author of this commit. And in brackets, I have my email address. And this is one of the reasons why Git requires that initial or minimum configuration that we went through earlier. Then we have the date that it occurred. And indented a bit, we have our actual commit message associated with that commit. Underneath, we have a bit of a diff, but that's not really all that important because all that was included in this commit was adding a file and all of its contents. If on your system you have a lot more information here, or that your prompt it doesn't come back to the prompt immediately, press Q to get out of it. For the longer styles or the longer show commands, it will use less under the hood. And so the less command requires the Q command, the Q key to exit out. All right. Now, we have 2 commits that are in our repository, but nothing is on GitHub yet. All right, so this is the full process that we just went through. We started in our working directory. We added our changes into the staging area, both new files and modifying existing files. And all those changes got put into the Git repository as commits. All right, we need to send our changes back to GitHub. Now, as I've mentioned before, if I haven't, the commits that we've done are actually all local. The repositories that we have, both our local repository and the repository on GitHub, are technically separate repositories. And we established sort of this loose affiliation with what we call remote reference. Now, I'll get into that in just a moment. So we have our 3 local states that we've worked with before, and now we need to do a push to put all our changes from the Git repository into the remote repository. So let's do that. Starting out Git status, we can see that I'm 2 commits ahead of origin master. So let's see what that means. What is origin master? Well, when we did the git clone command, the git clone command actually did some things for free for us. It set up that relationship between our local repository and the remote repository because it knew where we came from. And by default, it set up this initial relationship between the local repository and what we call the remote repository in what's known as a remote reference, and named it origin. We can see that with the git remote command with a -v for verbose. Now, it may look a little confusing that this is actually listed twice. 99% of the time, they are always going to be the same thing. However, technically, Git does support the idea of having Git does technically support the idea of having different references or different URLs for what's known as the fetch reference and the pull and the push reference. And that's really kind of an advanced usage. For the most part, it's the same thing. So since it's set up, we know that we can use our push command. Now let's go ahead and head over to GitHub. If we refresh our page, we can see that we don't have any changes we've made. We just have the README file like before, and we're still on the initial commit. That's that first commit that was made for us, that GitHub made for us on behalf of us when we created that repo. So now, we do git push, origin master. So git push is the main command for pushing. Origin is the name of the remote reference that we're going to push to. Technically, we could have other remote references. So, for example, if you have this repository also on GitLab and also on Bitbucket, those might be set up as different origins or different remotes. Then we have the branch we want to push, which is master. Now, since we are changing the repository, this is the point at which we need to log in to GitHub. And if you're on Windows and you did the credential, you did the check mark for installing the credential manager, then you should have this little dialog thingy show up that will allow you to log into GitHub. So I'm going to log in as Radiant Student. And as long as I provided the correct credentials, we should get something like this. Now, the first several lines is really sort of, inside information type stuff. It's really technical stuff that is, managing how Git works and sending its data up to GitHub. The last few lines are the things that are most important to us. In particular, the last two lines, where we are sending to, and this is the URL to our repository on GitHub, and then the commits that are involved, basically sending master to master. Now, if we do a git status, we are again on the master branch, and that we are up to date with origin master. So we said we're good. We're all synchronized up. Let's go back to GitHub, and if we refresh, we should now see our changes. We have the last commit that was involved that's listed here. We have 3 commits instead of 1. If we click on the commits, we can see that we have our initial commit that we started, and this was in reverse chronological order. And then we have the first commit that we did on our local system, and then our second commit that we made on a local system, which is actually the 3rd commit overall. Now, if we go back to the top page, we can see the 2 files that we added, plus our README file that we had originally. All right, and that is it for the remote first approach. For now, I'm going to close this out. And back on this side, you can see that we now have our file, all our changes on our remote side. So this is the full process with the remote involved. So we have the 3 stages on our local side, including that 2-stage or the 2-phase commit with the add and the commit. Then we push all our changes up to GitHub. All right, we've been using Nano as our text editor so far, but if you want to use something more graphical for your text editor, which most people do, then I'll walk through at least the text editor I like using, which is Atom. The process here is we're just going to install Atom. We do that on Windows, Mac, and Linux. Actually, I already have Atom installed on my local system, I believe. But I'll walk you through the steps I took to install Atom on my Mac. It is a little weird. It's not as simple as you might think. Or it's simpler than you might think, but it doesn't have an installer per se. There's a little tweaks that I usually make to Atom for better readability, and I'll just do that on one of the systems so that we don't repeat the thing over and over again. And that I will change the Git integration, the core editor setting, so to make that Atom instead of Nano, which is what we have now. And again, this is under the idea that I like to show all my work. And so, but if you don't, that's okay. You can probably figure it out. Just go to atom.io, and it should just provide you the download button. So click away, and let's go ahead and start this out on Windows. Let's open up our browser, which is Chrome. You can use whatever you want. And go to atom.io. Once that page loads, you should have a nice little download button. So let me get myself out of the way here. I'm going to click on the download button. Once the download has completed, let's go ahead and use our browser's run feature or open command to fire up and install Atom. Now, there's really nothing to do. There's no install wizard or anything like that. We just have to wait for the Atom installer to launch, and it just takes it from there. Once the installer has completed, it will automatically launch Atom. So at this point, it's just a waiting game. All right, we finally have the Atom icon show up on the desktop. Yay. Now we're just waiting for Atom to launch. All right. When you first launch, or when Atom first launches, there's going to be several little screens you have to go through. You might be asked to register something. Sure. I'm going to tweak this a little bit. I want it to fit a little better onto my screen. All right. So with the welcome screen, I'm going to uncheck items here to make sure this doesn't show again. And I'm going to close that and close this as well. And yes, the telemetry I don't care about right now. And I'm back to just an untitled empty document. Cool. All right. Let's go ahead and change a few settings. This is mainly for the benefit of the rest of the course because this is still kind of tiny on my screen. So if we go to File, then Settings, go to Editor, the default is 14. Let's try 24. All right. And we can actually tweak the style sheet. Yeah, we'll tweak the style sheet. Under the hood, Atom is actually built upon web-based technologies. So HTML, CSS, and JavaScript all working together. Atom is built upon a framework called Electron, and which is also shared by Visual Studio Code. So both Atom and Visual Studio Code share Electron. There are several other apps that use Electron. For example, I believe Postman for doing REST calls and stuff like that, for troubleshooting REST, is a popular client for doing REST, is built upon Electron as well. I believe Slack uses it. There are several utilities that use Electron. But because of that, we can actually use web-based nomenclatures to make changes to it. So we're going to do the style sheet. And since, of course, Atom understands this is a style sheet, it will provide me some assistance. So font, I want font size. For the tree view, let's try 16 point. Now, tree view is going to be something that will appear on the side, like in a different panel, that will show us a hierarchical view of our current directory or whatever projects that we're in. Now, we don't see it right this second, but we will in a minute. I can also set the font size here, 24. You can see immediately this takes effect when I save. So I used Control S to save, but I could also have gone into File and then Save. All right, now that we're done with that, I will close the style sheet. And let's go ahead and close Atom. Let's exit out of Atom. I'm done with the website, so I'm going to close out of Chrome. And now what I want to do is I want to add Atom to my taskbar and my start menu. I'm going to right-click on it, and I'm going to pin to taskbar. So now it shows up down there. And now let's pin to start. So this one's a little harder to see. You have to open up the start menu to see it. And now it's here. Now, earlier I actually set up a group called Tools. This is where I've been putting all my items that are related to my courses. So I'll put them all together here. All right. Well, let's make sure they launch from our respective new places. So do it from the taskbar. Looks a little weird because now I have two of these here. But that's okay. I can kind of figure out what's going on. It launches kind of in that same configuration I left it before. And now let's try it from the start menu. All right, so either way we get there, we kind of have the same results. While I'm here, let's test things out with accessing a command that should have been installed when we installed Atom, and that is the Atom command. We'll start with the Windows command prompt. Handful of people still use this thing for some reason. If that's your favorite deal, then if you go into the Windows command prompt and simply type Atom, then Atom should launch. And of course, like a lot of editors, you can specify a file name you want to open or a file name you want to create. The same thing. We're going to close our Windows command prompt, and now we're going to fire up Git Bash. Same thing. Let's just make sure we can open it from here. Yay! We have our Atom editor available from Git Bash. Super. Now that we've confirmed that we can open Atom, let's change our Git configuration to use Atom as our default editor. Like we've done before, git config -- global core.editor. Then in double quotes, we type Atom. Then I want to put space -- wait. That tells our git command that we need to wait for Atom to save or exit out before we continue. Great, let's test that out. Git config -- global -e. Again, like we've done before, this uses Git's internal or internally registered or core editor to display our configuration. All right, now we have our .gitconfig file, and as I mentioned before, it opens up our user's home directory as our project. This is the tree view that I was talking about earlier. All right, let's go ahead and close our .gitconfig file, and we can exit out. Now we've returned back to our terminal. That is it for our Windows install. So what we did is we went to atom.io. It detected who we were, that is a Windows-based system, provide the appropriate download button. And there's nothing really to do except just let it do the install for you. We added Atom to our taskbar and start menu. We adjusted some settings for better readability, and of course our Git integration. All right, macOS. Now I'm back on our Mac operating system. If I bring up my dock, now I already have Atom installed, but I can show you the steps I went through to get Atom installed. So fire up my editor, or fire up Chrome, go to atom.io. It's going to detect that I'm running macOS and provide me the appropriate download. So I click on the download button. It's actually going to download a zip file. So that's a little weird for some people. It's going to be available in my downloads folder or download stack. If I click on this, I can use the archive utility to expand out the zip file. And that will normally then bring up Finder in my downloads folder, and I can see I have my zip file and I have this Atom app. I can simply, to install, I simply drag and drop into my applications folder. I did that a little too slow, so let me make sure I do that right. So click on it. I'm going to drag and drop it into applications. All right. I actually had Atom open, so I had to quit Atom before I could copy over it. Minor detail. All right, so now I'm going to drag and drop the Atom app into the applications folder. Let me bring you. If you already have Atom installed, or this, you can actually use this as an upgrade path. It'll prompt you if you want to replace Atom or keep both. I'm going to replace it. I'm going to upgrade, basically. I'm going to use my password. In this case, I have a touch bar with the fingerprint sensor, so I just use that. And if that's successful, then the Atom application should disappear from the downloads folder because it got moved into applications. So while I already had Atom installed, I effectively just did an upgrade. So I can either launch it from here, or I can use my application stack, which is usually how I have things set up, and then I'm just going to launch Atom. While I'm waiting on Atom, I'm just going to close the web browser since I'm done with it. It's going to verify, and of course, since this is something I downloaded off the internet, macOS is going to prompt me to make sure, hey, you know, not sure about this, are you sure? So I can click on Open. To have a security feature built into macOS. All right. Kind of same thing here. Since I'm on a huge screen, I'm going to take the opportunity to make a few adjustments. So we'll go ahead and resize this a bit. Provide easy access between my terminal and Atom. Like I've done before, let's go ahead and change some settings around. So in Atom, the menu bar is up here like a typical macOS system, like a typical macOS application. It's from the Atom menu item, go to Preferences. That brings up that other screen that we're familiar with. Click on Editor. You set this to 24. Let's change to Style Sheet. Go to Atom, then Style Sheet. You change this to 16 font. Under Text Editor, font size. That looks pretty good. All right. So I'll make sure that Atom is running. And let's make sure that we keep in dock. So we go to the dock while the app is running, and then we click on Keep in Dock. That way, when we close Atom, go to the Atom menu, then quit, we still have access to Atom from our dock. That's usually how I like to run Atom. We also need to make sure that our Atom commands are available to us in our shell environment or on the terminal. So we go to Atom and then install shell commands. Then hopefully it'll tell us that Atom and APM are installed. APM is a way of installing packages in Atom via command line. If they're not already installed, you might be prompted for your username and password. Just keep that in mind. So let's test out our Atom command. So back in the terminal, we simply type Atom. And there we go. Atom launches for us. And like we've done before, we'll do our git commit command. We'll do our git integration. Change that over to Atom. Git config -- global core.editor. Then in double quotes, Atom space -- wait. Like we've done before, using git config -- global -e, we can force Git to use its core editor to display the git config file. This kind of confirms that Git is in fact set up to use Atom as its core editor. All right. And you see that with the wait -- wait, you can see that we haven't returned to the terminal yet. This works on Git Bash on the Windows side as well. I just didn't point that out. The moment we actually close this file, we return to the prompt. So keep that in mind when you're working with files within Git. All right, let's close out and use quit as Command Q. And that's it for installing Atom on macOS. So I'll clear for now. All right. So Atom on macOS. We went to download and install. We went to atom.io. We were given a zip file. We unarchived the zip file and moved the Atom app into applications. Then we added the dock while Atom was running. We adjusted some settings for better readability, and then we did our Git integration. All right, Atom on Linux. And of course, like I've mentioned before, I'm using Linux Mint. In particular, I'm using Cinnamon, which is one of the many flavors of Linux Mint. It's just I think it's based on GNOME 3 desktop. And Linux Mint itself is based on Ubuntu, which is part of the Debian family. There we go. All right, so we're back where we left off on Linux Mint. Fire up Google Chrome. All right. Once I'm here, like we've done in the other instances, we're going to go to atom.io. Go ahead and get rid of myself. And it should detect that we are running. There we go. Had to scroll down a bit. That we're running on Linux. And that is going to say, oh, well, if you're running on Linux, here are your options. You can download a .deb file, which is for Debian-based operating systems or Debian-based distributions of Linux. And it provides us an RPM file for the other side. That is the Red Hat, CentOS, Fedora crowd. Since I'm part of the Debian family, I'm going to get the deb file. Once that is done downloading, you see that I got a 64-bit version of the deb file, which is good. I'm going to click on Open. And on my system, it's going to invoke a graphical package manager. Just give it a moment to sort of pop up here. All right, so we have the package installer, and it's going to figure out if there are any dependencies that need to be resolved. And right now, all the dependencies for the Atom package have been satisfied, so I'm good to go. And it provides me the option to install the package. So I'm going to click on that to get that done. It's going to require that I authenticate. And now it's installing Atom. All right, at some point, you should come back. It'll now say reinstall package, which means you're basically done. And now we can close the package installer. Let me close out of that. We're done with Chrome for now, so let's go ahead and close out of here. Now, when Atom installed, it put it underneath the menu system. So we open up our menu system. I believe it's under programming. So we go to programming. We should have this item called Atom. While we're here, let's right click and I'm going to add to panel and then add to desktop. Let's add to panel first. See our Atom icon popped up on our taskbar or panel. We do the same thing again, but this time for desktop. That's really where I prefer to have Atom. And now we're good to go. I could also add it to my favorites, which puts it over here. So we have it in, I guess, now 4 locations, because it came on the menu system within our menu. It's on our favorites, and it's on our panel, and it's also on our desktop. When Atom installed, it should have also installed an Atom command. If I do which Atom, it should tell me that it's under USR bin Atom. If I simply type Atom, it should launch. And of course, since this is the first time I launched Atom, I'll have all the welcome screeny stuff. So I'll go ahead and uncheck, close, close. Don't care about telemetry. Now we're good. Kind of readjust this window a bit. Like the reposition thing so that I have easy access to both terminal and the editor. So, and I like to keep the terminal such that I can have easy access to the icons that are on my desktop. There we go. That looks pretty good to me. Like we've done before, we'll make a few tweaks for better readability. So go to the file, and it's not here. There we go. On Linux, I guess it's under Preferences. Let's go to Preferences. There we go. So edit Preferences. Now we're going to go to Editor. All right. Make this 24. Same thing. I expect the style sheet to be here. And there's nothing here before, so font size 16. In fact, let me just steal it from one of the other environments. Tree-view. So make sure I have tree-view. Tree-view. That's correct. Then Atom dot dash editor. And that one does not have a dot in the front. Atom-text.editor. All right. Atom-text-editor. Font-size. This looks like pretty big, so maybe we'll try 20. Let's see how well that goes. 24, does that make it bigger? All right, let's try closing and see if it makes a difference. Yeah, pretty big difference. All right. All right, looks good. That might be a little too big, actually. Let's do that. You have to sort of play with it to see what's best for your system. That looks a little better. It's large enough, but still I can have a reasonable amount of text on the screen at the same time. Cool. All right. All right, now that we've done that, we've confirmed that we can invoke the Atom command from our terminal. We've set up Atom in all the different places on our system for easy access. Now let's update our Git configuration. So git space config dash dash global, like we've done before. Core.editor. And then in double quotes, Atom dash dash, space dash dash wait. And now that should be set up. So we can test that out. Git space config space dash dash global space dash E. Like we've seen in all the other systems, Atom opens with the .git config file loaded. Like before, our terminal is waiting on us. That's part of the dash dash wait option. The moment we close the .git config file, we return back to the prompt. All right. Now let's close Atom. All right. We are done with our Atom install. Super. We went to the atom.io website. We downloaded the appropriate package for our distribution. And really, they only support 2 distributions at the moment. There are the Debian family and the whole Red Hat family. If you are something else, well, you might want to have, I think they do have an option for you to compile from source, so that might be your only option. In my case, when I used Chrome to download, I was then able to have the system recognize the deb package, which would invoke the package manager to do the installation. Then I added the panel and desktop and the favorites as well. We adjusted our settings for better readability and also did the Git integration. All right, so now we're ready for the final piece of this quick start, which is the local first workflow. So why start local? Well, actually, I prefer starting remote. I mean, you might think that's kind of funny. Hey, why would you bother showing us? But, some people prefer starting local, or maybe they have a bunch of source files. They think that they need to start with the local side anyway because of that. A lot of times I think it's just easier to start remote and then just copy and paste your files over. So if you want to do that, it's fine. The overall, I think there's less setup. Now, if you want to start local, that's okay. If you're unsure like which remote you're going to use, like which hosting service, that might be like your option you want to do is you want to start on the local side. Again, it's kind of a personal preference how you want to go. Of course, if you have a ton of existing source code, you'll probably want to use the starting local approach. Well, you could use the remote first approach, and you could do that by walking through those same steps. And once you have a local repository that's hooked up to your remote repository, you simply copy and paste or move all your files into your new repository working folder. Add all the files and commit all the files and push them up to your remote, and you're done. So either way is fine. All right, so let's start with our completely empty folder. It's like completely, like nothing, just completely fresh. And I'll do this on our Windows system. Actually, let's do it on Linux. And mainly we're going to do it on Linux because I just want to prove all the Git commands are basically the same. It doesn't matter. So we have, you can see that I'm in my user's home directory. In my case, it's /home/Jason. That's my user account. I have the ll command already set up as a bash alias. And if I look here, I do not already have a projects folder. Let's fix that. mkdir projects. So now I've created my projects folder. And so you can see now I have projects. If I just do a simple ls command, it just lists everything that's not a .file or folder. So basically all the standard files and folders are listed. go into my projects folder, and this is where I will start things out. All right, let's create a new folder, git init, using the git init command. So basically, we would say git init and then the name of the folder we wish to create. So that will be local-demo. That's sort of separate from the GitHub-demo that we did earlier. So now it tells me that local-demo.git has been initialized. Empty git repo. So now if we do an LL, we have a local-demo folder. If we go into it, we have nothing here. It might be a little easier to see from the top. All we have is the .git folder. Like we've seen before, if we go into it, we get the nice little warning in parentheses. We have those internal files that we saw earlier. So I'm going to back out of it. Now we're back into the working directory of our local-demo repo underneath projects, underneath our home directory. Now, let's see what Git thinks of us. Since we are technically in a Git repository, even though there's nothing here, we can still do our Git status. And it tells us there's no commits yet. And we're on a master branch. You get that for free whenever you create a new Git repository, which we have, a completely empty, completely fresh Git repository. All right, so let's create some content. Let's do that. I want to use a service. Let's open my browser. Let's just get some filler text. Go to hipsum.com. I do not know why. All right. Obviously, I made a little mistake here. Let's try that again. Hipster Ipsum. Just do a search for Hipster Ipsum. That's better. Now if you do this, that's a little better. That's what I meant to go. Hipsum.co. Don't go to hipster.com. Hipster.co. Basically, this is just a hipster flavor of the ever-present Ipsum, the whole Ipsum, lorem ipsum filler text. So let's go ahead and say how many paragraphs we want. 5 should be fine. Hipster neat just means it's mostly the hipster nonsense. And with a shot of Latin, also puts in the Latin text in there too. Doesn't matter, either one's fine. And I like starting with lorem ipsum. It's sort of the standard deal. Beer me, just give me the text. So here we are. We have, and you can just look here. It's just a funny way of getting filler text. It doesn't really matter. We'll kind of leave this open because we'll be coming back and forth to this. I'm going to copy this and head back over to my terminal. We're going to use our newly installed Atom text editor to create our text file. and call it hipster.txt. Once that loads, we can see that since we did it from within our Git repository, it loads our repository here. We have our .git repo, and this icon here sort of denotes the fact that we're in a Git repository, which is kind of nice. Let's go ahead and paste in that text. And Control V. And now it's save. Again, nice little green text, nice little green icon, or green. The name of the text file shows up here in the project, and it's green, which notes that it's a new file. So now I can exit out of Atom. Now we get status. We have an untracked file. As I mentioned before, now if I do a git ls files, it returns nothing because Git is not tracking anything right now. It's, since it's a fresh repo, there are no commits, there's nothing in the staging area, Git has nothing to track. Let's fix that. Git add, and then we can add our hipster file. Now if we do git status, we have our new file in the changes to be committed state. So that's where we are. All right, so we can continue forward with our new file, and here's our initial commit. First commit, hipster.txt file. All right. Git status. Now we're back on our master branch, and there's nothing to be committed. Now there's one distinction here, and that is that normally we would have origin master up to date with your local branch or whatever. We don't have that here. We are completely detached from any remote type repository. We're just on our own local repository. That's perfectly fine. You can have local repositories or Git repositories that live exclusively on your system. There's nothing wrong with that. All right, so let's add some more commits here. We just have our hipster file. Let's add some more files, actually. Do another .txt. That opens up our another file. And we had the other file open, and so it was listed with us. Here it is. We have this file. It's a brand new file. You can see we have this marker here that indicates this is a new file and it hasn't been saved yet. So let's head over to our web browser and let's get some more content here. And it really doesn't matter, it's just filler text. So you can just paste this in. Let's just save it. So now we have another text here. If you want to, we can simply use Atom to create new files. So we don't have to exit Atom, create another file like that, keep going around. We have a third file. We're going to paste this in as well. I'm going to save. You see now we have 2 files here that are green, indicating these are new files according to Git. There is a pretty deep integration between Atom and Git, which is pretty nice. That's something worth exploring. You can close these files out as you are done with them. We could even open up the original hipster.txt file, and maybe we'll add some more text to it as well. Oops. There we go. More content. Again, doesn't really matter. Here we actually have like kind of an auburn or amber color here, signifying that this is a modified file. All right, now we're done. Let's go ahead and close out of Atom. And let's go down a bit more. We may want to use some more of this content. All right. Now, let's do git status. What do we got here? Well, we have a modified hipster.txt, and we have 2 untracked files. We can see that with our git ls-files. It shows that we only have hipster.txt being tracked because we've already added this to both the staging area, and eventually we committed that into our repository. All right, so to add all the changes all at once that we have pending, we do git add, and we can do a period. When we do the period, that means we're going to do all the files. Now we do that. Now we do git status. Now everything is in the staging area. We have our new file. We have 2 new files. We have another.txt and third.txt, and we have our modified files. Now you're probably wondering, like, why would you use an add command for existing files? And the way I think of it as, we're just simply adding the modifications. So that's what you do when you're modifying existing files. You're not adding a file, you're adding the modifications to the file. And that's really what Git tracks anyway, are the changes to the content. So git ls files shows that now we are tracking all 3 of those files. Let's move forward. This time, just for grins, I'm not going to use the -m option this time. I can just leave it off, and if we leave it off, Git is going to invoke our default or our core editor to provide the commit message. So that's what we want to do. So when I do that, it's going to invoke Atom, since we have configured Atom to be our core editor for Git. When that loads, we are automatically Atom is loaded with a special file provided by Git, which is commit_edit msg, or message. If you can see that Git is patiently waiting for us to return from our git commit command. So we have to save this special file in order to return to our prompt and continue with the commit. As part of this, Git is nice enough to provide us a status, the contents of the status, all in these hash marks, which signify commit message. I mean, not commit message, but these are comments. So when you do this, you're providing documentation, if you will, as part of this file. These are commented out. This is what that means. So within these comments, we have the contents of our last git status. So you can see how that lines up. This is nice because this kind of tells us what's going on with our commit. So everything that's in our stage area will be going into our commit. So if we know what's in the commit or what's in the staging area, we know it's going to be part of this commit. So we can provide a more informed commit message. So adding new files to our local repo. Let's say on a new file, let's see how long was that. 35 characters. That's good. That's another benefit of using a nice text editor. You get some neat features that you can leverage. Also, using your own text editor, you can have multiple line commit messages. There we go. It's kind of a joke, but you get the point. All right, now that we're done that, watch this. I'm going to save my changes, and then we'll continue with the commit. So I'm going to use, in this case, it's Control S. That allows me to save, and we're going to return back to our command prompt as we exit out of, once we exit. So we did our save, and now we're going to quit. All right, now we're back. When this happens, it's going to run the commit message kind of all together. So it's not going to really preserve all those line endings as part of the way it shows it here, but no worries. It is actually preserved within the Git repository, so we're okay. It also tells the commit message we're involved, the commit ID that's involved. It tells it how many files were changed and number of insertions, so each line we inserted. We had 2 new files. So we have another.txt and third.txt. To get status. Now we're on a clean working directory, or the clean working tree. That is, the whole point of the tree is that it's a recursive, it's the whole folder structure from this point downward. So now let's show the actual commit here. And this time I'm going to use the name of the branch. So git show master. I just wanted to show the commit with the multi-line commit message being preserved. And you can see here, after my name and the date, that we do in fact have the full commit message with the line endings preserved. So it's on multiple lines, which is all indented, so it's easy to read. And that's it. That's we have more to it here because we have a fairly long diff, because we have lots of different changes as part of this commit. If you find yourself in this situation, you have a little colon here waiting for your input. Press Q to exit. All right. Well, if you want, we can add more content here. It really doesn't matter. Let's add more stuff to our hipster file. All right, so we'll add this in. Oops. There we go. Paste. Now let's save. And let's close out of Atom. So I've made some more changes. To git status, we have our modified file. Since this is modified, we can actually do what I call the express commit. That is, in a single command, we can go through the staging area and then directly into our commit phase. So let's do that. So git commit -a. Now we could just do the -a like this and then use our default editor, our core editor, that is Atom, to do the commit message. Or we can do a -m. We can actually combine the two into like this kind of a syntax where you have -am and then the actual commit message. Okay, express commit coming through. All right. Make this a little easier to see. We have a git status now. We are back to a clean working directory. All right. Let's set up for the next thing we're going to do. So we do an ls-al, which is actually the same thing. I have my ll command. Make this a little better here. ll to have all the files and folders listed. I do have that funky .git folder, which is the whole reason why this folder is being managed by Git. So in order to set up for the next phase of what we're going to do, let's actually remove this. So right now, if we do a git status, since we're being managed by Git, the git status command will return and tell us we're on the master branch and there's nothing to commit because we just finished with a commit and everything's all nice and tidy at this point. If I do an rm-rf, so the -r means recursive. The -f part of it means by force. So really, kill everything that I'm about to tell you to kill with malice. And then the .git folder. So this is actually a very dangerous command. So just make sure you do it on the right location. Now, I wouldn't necessarily recommend deleting your .git folder. I'm doing this for really illustration purposes. If I do this, now you can see that my prompt actually changed. So before, I was in parenthesis master. I was on the master branch. Well, now it disappears because I'm no longer actually in a Git repository anymore, or a working folder being managed by Git. It's completely here. This is it. There's no .git folder. This is no longer a folder managed by Git. It is just a folder on my system. So now I can prove that by doing a git status command, and I get an exception. I get an error message from Git. It tells me, hey, you're not in a Git repository. And it tells me I can't find a Git repository anywhere in, all the way down. There's nothing here. So it is possible that I could be in a Git repository, just maybe not at this level. So it did a search all the way down my directory tree to make sure there's nothing, there isn't a Git folder that it could latch onto. So, yep, not being managed by Git. Let's back up a level here. So this is where we are. All right. So now I have my local -demo, and that's it. Now, let's kind of pick up where we left off. And we're doing this to kind of simulate what it would be like if you had a project already that you want to put under source control. So basically, we're placing an existing project with code under Git management. So let's do that. So we're going to use that local -demo that we had before. Now we just removed the .git folder, so now we're not being managed by Git any longer. So this is just a folder on our system with code or with text files or whatever we want to manage with Git now. To do that, we can use the git init command like we did before, but a little bit different. Git init, but now instead of the name of the folder, we simply say here. And we do this from within the folder we want to start managing with Git. Now it says initialize empty Git repository. Now, our folder isn't empty. It's just the repository is empty. That is, there are no commits involved yet. And it tells us that we did a .git folder under the local repo, the local -demo folder. And the moment we did that, of course, we now have master in parentheses, because by default we get a master branch. All right, so we can do a git status now. And now it says, hey, you're on the master branch, yay. And now we have untracked files. Now you're probably wondering at this point, if we do git status, hey, what happened to, the Git repo and all that previous history? Well, when we removed the .git folder, we deleted all of history, right, for that Git repo. It no longer exists. When we initialized, it's like starting fresh. We have a completely new repo. There are no commits yet. There's no history, no revisions, none of that. So it's completely starting fresh. And Git is not tracking anything yet. So we do our git ls files. We have nothing to list because Git isn't tracking anything. It sees that there are new files in our working folder, but since we haven't added them to the staging area yet, it's not actually tracking them yet. Well, let's go ahead and fix that. Like we've done before, we can use the period with the git add command, like this, to add all the files. There's another one we can use, -a. Now, there is a slight difference. If we were to delete something that's already being tracked by Git, then using -a would pick up on that. If we use just the period, we're just adding new changes or new files. So that's really the distinction. If there are deletes involved, use -a to get everything. So -a means all. If we do that, now we do a git status. We have all new files being added. They're now in the to be committed, that is our staging area. Git ls files shows that we're now tracking all three of those files. Now if we do git commit, we can use our text editor, that is Atom, to do our initial commit. Initial commit. Adding all project files. All right, let's save our changes, and then let's quit. All right, now that we're done that, we have our commit done. So we've added those three files. Now we do git status. We're on our master branch, and nothing to be committed. And we have a clean working tree. Git show master shows us the last commit on our master branch. So it has my name, author, the email address associated, the date, and then our multi-branch, our multi-line commit message that's indented a bit. We have a pretty long diff here, but we're actually just comparing against nothing. Since there was nothing before it, we're adding all the files. And let me show you the git status. We have the LL. Now we have our files. Now what happens if we delete a file? Let's get rid of third.txt. It's sort of the third wheel here. We could use the standard rm command, which is available in our bash environments. We could actually use Git supports an rm command. So let's do that. Git rm and then the file name. By doing that, we remove that file from source control. We have git status. It shows in a deleted state. That's in the changes to be committed. So basically, this is staged. This deletion has been staged. Now, if we do an ls, we can see that the git rm command also took care of the file on the file system, which was nice of it. Let's go ahead and get rid of the other one. I'm going to use the regular rm command. Rm, another, .txt. So now it's gone from the file system. So now we only have hipster.txt. So git status. Now we actually have deleted, but we have two files, but they're in different states. We have to be committed. That is the first file we deleted, which is third.txt. And then changes not staged for commit. This is something we did on the file system, but we didn't tell Git about it. It just noticed, hey, you removed my file. So we could use the git add or git rm command to finalize or to actually take care of that. We could also git add -a. And now if I do git status, actually let me clear here, git status. Now it shows both another and third in deleted state. Now, git commit, removing files. There we go. That still leaves us with hipster.txt, which we want to keep. Well, for now anyway, for our demo. All right, GitHub repository. Now the trick here is that we, let me see here. We don't actually have a Git repository on GitHub for this code. Now you're probably wondering, hey, why not just use your existing repo? And there's a very simple answer to that, and that is they're separate projects. Different code base, completely different timelines. We don't want to mix and match here. All right, so now let's go back, and we're going to, so you'll notice here that we do git status, like we don't have the line that tells us that we're up to date with origin master because there is no origin master. So let's fix that. In order for there to be an origin master or some place to push our code to, we need that place to push code to. That needs to be a repo on GitHub. So let's close our existing tab. And we reopen Chrome here and go to GitHub. And let me sign in here. Yeah, sure, why not? Oh, whatever. So we're signed in. We have our original repo that we created earlier, the GitHub-demo. We don't want to put our code in there because it's a separate project or a different project. My rule of thumb is if it's a different project, you need a different repo. So I'm going to create a new repository. Once we're here, we'll create a unique name for our repo. So if we do GitHub, it's going to tell me, hey, this repo already exists, right? So we can, it has to be a unique name for this account. So I'm going to use local demo instead to keep it consistent with the repository name we have on our local system. A description, whatever you want to do. This is a local repo example. We'll keep it public. Like I said before, we go to private, it wants you to upgrade. Yeah, we're not going to do that. Now, this is the thing. Before, we initialized this repository with README, but we don't want to do that. If we do that, then we'll screw ourselves up. We'll end up with commits, and then it'll just get weird. We don't want to do that. So instead, we'll not initialize anything. We're going to make sure git ignore is set to none, the license is set to none, and we're not initializing this repo. With all that, you double check, make sure everything looks good. Now click on Create Repository. All right, when you create a new repository on GitHub and you don't initialize it with anything, you get this nice little set of instructions. So we're going to go down to the piece that starts with git remote and git push. This is adding to an existing repository from the command line. This is what we're doing. So we're going to take the first line and we're going to copy it. And we're going to jump back over to our terminal and we're going to paste it in. That looks a little weird, so let's verify that got set up right. So git remote -v. So now that we've pasted that in, press enter, we have that set up right. All right. Now let's head back over and do the second line. All right, before we do that, I wanted to actually go over what this first line meant. So we're going to use the git remote command to add a remote reference named origin. And then here's the URL that our remote reference named origin is pointing to, which is our URL to the repository. So it starts with HTTPS, which is the protocol we're using, github.com, which is our service, and Radiant Student, which in this case is my user account on GitHub. It'll be your user account on GitHub, hopefully. And then the name of the repository you're actually using, .git. That's sort of how the .git is sort of tells GitHub, oh, this is a .git repo or whatever. All right. Now, the second line, we're going to start with git push. And really, we've already done this, right? So we git push origin master. We're familiar with that. The little kicker here is the -u piece. And that's an option that we're using with our git push command to set up a tracking branch relationship. That is saying that my local repository with the master branch is pointing to or tracks against the master branch on origin. So let's copy that and let's paste it in. So here we go. So git push -u origin master. Now it prompts me for my username and password. So I don't have that neat little dialog that I got on Windows. So I have to put my username and then the password for my user account. And if I did everything correctly, we should have something like this. So the main thing is that at the very end, we have 3 lines that we really care about. That is to our URL to our GitHub repository. That's where we sent our changes. Then the next line, in brackets, it says we have a new branch. So basically, technically, the uninitialized Git repository doesn't have anything set up yet. So we did our initial push. We set up that first master branch and that initial commit. Then the last one is courtesy of the -u option. That is, that branch master is set to track the remote branch master from origin. So that -u sets up that relationship. So now we can simplify things. So now we have, if we do git status, now we have the that verbiage where it says your branch is up to date with origin master, which is what we saw when we were doing the remote first approach whenever we did our git status, because we had everything linked together already set up for us, which is one of the reasons why I really like doing a remote first type approach, because everything's just already set up for you. All right. Now, let's head back over to GitHub. And now that we've pushed our changes, all we have to do is refresh our page. And now we have our Git repo. We have our hipster.txt file and our initial commit right here that this file was associated with. The last commit itself was actually us removing files. You can see we have our 2 commits involved here. And we have our commit messages as well. All right. All right, I know this has been going on for a while, but here it is. This is the end. We're going to continue working. And we could have done this on the remote first approach, but I didn't want to do it twice, so we're going to do it here. Basically, the idea is, okay, now we have a repository in GitHub. We have this association between our local and our remote repo. Now what? Well, we just keep using it. You go back here. Let's start on the remote side. So if we look at our repo, GitHub really likes pushing the whole README file thing on us. So let's succumb to peer pressure and click on Add a README. This does the whole thing where it does the hash mark, which signifies a header of 1, the top level header. I'm going to change this a bit. So local first repository example. And let's go ahead and make our commit. If we go to the bottom, we have an option to commit directly. Now, of course, on a web interface, there's no way to do a staging thing, and then, I guess they could, but they didn't. So we just do our commit message directly, and it's going to take these changes and go straight into the Git repository on GitHub. So if we don't do anything here, we don't actually have to fill this out. In gray, this will become the commit message. So create README file. We can do that. I'm okay with that. So click on commit new file. And now we have our hipster.txt, which we had before, which we pushed from the local side, alongside our README file. However, now we're out of sync with our local version of our repository. So let's head back over to our local repository. So we're inside our working folder. If we do git status, it lies to us. Git is lying to us because it doesn't actually know that changes have occurred. It tells us we're up to date, but we know better than that. We can fix that. We can use the git fetched command. And since we have a tracking branch relationship with origin master, we don't have to specify origin master. We could if we wanted to, but we don't have to. We just say git fetch, and it does it. And it brings down the different changes and stores them kind of in a temporary location. It's actually in the Git repo. It's for our benefit of doing comparisons and stuff like that, but it hasn't actually integrated into the changes that have occurred. To do that, we actually have to do a git pull. So we do a git pull. Now we integrate our changes with our Git repository. Now we go to git status. Let's do that again. Git status. All right. All right, let's do that again. Go back up to GitHub. I'm going to change my README file. You see it's rendering out that first level header. And do the edit. I'm going to directly edit my file here on GitHub. Add another line. Just adding another line to README, and commit the changes. Go back to the local repo. You can see that's where we are. All right, we're back here. Git status. And it says, again, we're up to date. So again, we have to do a fetch. Fetch our changes, make sure we're up to date. The one thing I missed to show you is to do another git status this time. Now it says that we're behind origin master by 1 commit. It can be fast forwarded, and that's a kind of an advanced thing we're not going to cover. But basically, fast forward means you're good to go. So we're going to simply use git pull to update our branch, which is what I should have showed earlier. So here we are. Now we have our change. This is fast forward. It's basically a super easy, easy mode merge type thing. So we're able to bring down those changes to our local repository. So now we're up to date. So we do git show master, and now you can see that we have just adding another line to README, which is what the change we made on GitHub. All right, now let's make a change on the local side. So we pulled down our changes because there were some changes made on our local system. On the remote system. That is GitHub. Maybe it came from other developers. Maybe it's changes you made directly on GitHub. Whatever the case is. Now we want to make sure we have the benefit of all those changes before we bother doing any updates on our side. So you do Atom. I'm just going to open the local working directory by saying period. That just opens it up with no particular file open. It just opens the entire folder. That way I can kind of switch back and forth between these two files if I wanted to. So let's do more to the README file. So this was changed from the local side. That's all we need. We're going to save this, and I get that little indicator that this is a modified file from Git's perspective. I'm going to close the file, and now we're done. I'm going to quit out of here. Git status. We have a modified file. Git add, and let's just specify the README file. Git status. We're good to go. Git commit. I'm going to say more README changes. Git status. Now it tells me that I am ahead of origin master by 1 commit. Now our local side is ahead and our remote is behind. That's okay. Since we're on the remote side, we already have that information. If there's a lot of activity on your repository, you might want to do git fetch just to make sure there's nothing on the remote side you need to incorporate and be aware of. But for the most part, I know what I'm doing here, so I know I'm the only person modifying that repo, so it's pretty safe to sort of continue onward. So now that I have changes that have been committed to git status, you see that I have a clean working directory. All right, we just committed, we're good. But my local side is ahead. We need to push that up to GitHub. So let's go to our README file. So we don't have the benefit of that other line yet. So we will push that up. And since we have that tracking branch relationship, we can simply say git push. And Git will understand, oh, you mean origin master. Okay. Again, I need to put my credentials in. All right, now we should be up to date with origin master. Great. On the master branch, we're up to date with origin master, nothing to commit, clean working tree. Super. Now let's refresh. Now we have that extra line. So now our changes are on GitHub. Yay, we've made our changes. You can basically follow the same line of thought, this whole back and forth, push and pull, occasionally do your fetch. The fetch command is going to be non-intrusive. It's going to be a safe command to always run. You can do it periodically if you want. The only thing that could be an issue is doing the pull, which integrates your changes. And so that's one of the reasons why I like doing the fetch. And that's it. We are done with this example. All right, so now this is it. This is all that I have. All right. Basically, we are done. There's nothing more to do. So I'm going to close everything out. I want to thank everyone for taking time to join this presentation. If you enjoyed my style of teaching, do consider looking at my courses on Udemy and some other platforms. If you have our corporate account with Safari Books Online, I do have a special arrangement with Pact Publishing to syndicate my courses on some of my courses, not all of them. Some of my courses are available on Safari Books Online, and all my courses are available on Udemy. And so feel free to check those out. I'll have some of my content available on YouTube, and I'll be putting most of my content on Patreon as well. So if you would, support me where you can if you enjoy this style of teaching, and I will see you next time. Thank you. Bye.